Hello to everyone, my name is Adib Uddin Ahmed, working as a Assistant Professor Department of Electrical Engineering in Institute of Engineering and Technology, Lucknow. So, as we are discussing about the power system protection, this is the lecture 4 for power system protection. In this lecture, we will discuss about the classification of protective schemes. So, let us start. So, classification of protective schemes. Basically, we have some different type of classification of the protective schemes. One major classification of protective scheme is that the primary and the backup protections. We also have different type of protection scheme in different type of protections. So, in general, we have these type of protection schemes. First, we will discuss the overload and backup for the distance and overcurrent relay. So, the overload protection requires a current transformer which supply means the measure the current in a circuit and compares it to the predetermined value. So, what we have to done? We have compared the two quantities. One quantity is coming from the CT and another quantity we have some fixed value. So, we are going to compare these two values. There are two types of overload protection. One is instantaneous overload protection. We can say that the IOC, and another is time overcurrent protection, that is TOC. And the instantaneous overcurrent requires that the current exceed a predetermined level for the circuit breakers to operate. So, we have a two type of protection. One is instantaneous. So, one is for the instantaneous and another is time overcurrent. So, instantaneous is operate when current exceed the predetermined level. So, that when current is exceed from the predetermined level, the circuit breaker will operate, and the time overcurrent protection operates based on some time versus current curves. We have some different type of time versus current curves. So, that on these curve this protection is occur. Based on this curve, we have measured the current exceed a given level of the preset value of time. So, the current exceeds given level of the preset value is as compared to or as related to the time the circuit breakers fuse or some fuse or some protective scheme will operate. So, we have some two basic time overcurrent and basic instantaneous. In time overcurrent, we also have some timing factor. Now, again is earth fault or ground fault protection. So, earth fault and ground fault protection is very common. We have some earth fault relay in the domestic point of view, also we have some commercial point of view. So, this protection is very common because earth fault is very common in power system. So, earth fault protection also requires current transformers and senses an imbalance in three phase circuit. Normally, the three phase circuit having some balance, so roughly equal in magnitude. So, we can say that the phase currents will be same in magnitude. We have three phase currents I1, I2, I3. So, these phase current roughly having some phase magnitude when the load is balanced and there is no fault. So, earth fault or earth fault protection, what is done by the earth fault protection? If one or two more phases connected to each other, suppose we have some three phases and these two phases are short, or you can say this phases is grounded and these two phases are shorted and grounded. So, we can say that line to ground fault. Also have line to ground fault, both of the three lines or these three lines get short circuited and grounded. So, we have a different type of fault. In these type of faults, the current is not balanced. Current is not balanced. Suppose line to ground fault or line to ground fault, the currents in these three lines will not balance and these currents will change. And so, if you are talking about the impedance, so you can say the magnitudes will increase dramatically, or you can say the impedance magnitude is change. So, that the current will follow the less impedance path, so that the magnitude of the current is not balanced in the 3 of these lines. So, if this imbalance exceeds a predetermined value, the circuit breaker will operate, and the restricted earth fall protection is a type of earth fall protection which looks the earth fall between the sets of current transformer. So, this is a basic funda or basic phenomena that when there is a balance or unbalancing between the currents in these 3 lines, the 3 lines of the power system, the currents is measured by the predetermined value or of normal operating value. If the current having some over value, so that we can say that this is a faulty condition and circuit breaker will operate. So, this is some earth fall or ground fall protection. Now, the generator sets protection. So, what are the generator sets of protection? In the power system plant, the protective relays are intended to prevent damage of alternator or the transformer in case of abnormal condition of operation due to internal failure as well as insulation failures or regulation malfunctions. So, these such type of conditions are responsible for the power system protection failure or generator sets protection failure. So, generators is very highly costly devices. So, we want some very high quality protection that is used in generator protection. So, maybe the insulation of the generator, because we have some high amount of current draw from the generator. So, we have some high grade of insulation, and maybe insulation may be fail due to some temperature effect, due to some aging effect, and also we have some regulations, or we have some internal failure, some supply failure is occur, or some maybe some physical damage of the generator will occur. So, these are the possible conditions. So, in this condition the generator will not operate. So, if a protective relay fails to detect a fault, the resulting damage to the alternator or the transformer, because alternator and transformer both are very costly, might require costly equipment repairs or replacement. So, these are not wanted perspective, because we do not want to replace, or we do not want to pay such a huge money to the replacement of the transformer and the generator, because this will turn as a income loss and inability to produce and sell the energy. So, this is some interruption, this will lead to some interruption in the power supply, because no one wants to bear the cost, or no one wants to extra bear the cost, the replacement and the repairing of the transformer, because transformer having very high amount of cost. Suppose we have a some 53, 63 MVA transformer, so the cost of very high. Suppose the cost of this transformer is 2 to 3 crores. So, this is very huge amount. Now, distance impedance relay. Distance impedance relay is what? We can understand that we have different type of transmission lines. We have different type of transmission lines, and these transmission lines is connected the generating section to the distribution section. So, the distance protection detects both the voltage or current, and these transmission lines will and needs to be protected by the some surges, some fault, you can say the some ground to some ground fault, phase to ground fault. So, that is why these such conditions must be avoided for the healthy transmission system. So, very important factor that the transmission lines having a very huge amount of length. Suppose we have some 100 kilometers, 200 kilometers length. So, the fault and suppose there will be a fault in the power system. So, how we can detect the fault at that location? Suppose we have some transmission lines of 100 kilometers and fault is occur at that point. So, how we can understand the fault is occurred at that point? We doesn't want to check, or we cannot check the whole transmission line, because this transmission line having some long length. So, we do not want to waste our time. That is why we opt such type of protection that is basically depends upon the length of the transmission line. So, that is called the distance or impedance protection. And distance protection detects both voltage and current. A fault on a circuit will generally creates a sag in voltage level. So, the voltage will be down. If the ratio of the voltage to current measures at the relay terminal which operates to an impedance lengths with the predetermined level. So, this will, you can say, deviate from the predetermined level of the circuit breaker, so that this circuit breaker will operate. So, we are going to compare the voltage and the current ratio at the relay terminal and the voltage and current ratio on the operating point of view, or the relay and the current ratio of predetermined value. So, when there will be a change in the relay in the voltage current ratio, so that we can understand that there will be fault. This impedance, or you can say this is useful for reasonably long lines, because we does not want to take permission to use these such a type of long lines, because long lines protection having some complex procedures, or we does not want to lose, or we does not want to waste our time to check hold the lines. Maybe this is useful to reasonably long lines longer than 10 miles, because their operating characteristic are based on the line characteristic. This means that when a fault appears on the line, the impedance setting of the relay is compared to the apparent impedance of the line. So, we have two type of impedance, one is setting impedance, one is apparenting impedance, and when these two are impedance will compare and we have a some change, so that we can understand that there will be fault. As if the relay setting is determined by the to be below the apparent impedance. So, if relay having a some different type of setting and these setting having a determining the below the apparent impedance. So, if we have a some impedance and relay setting having a some low impedance with this apparent impedance. So, it is determined that the fault is within the zone of protection. So, we can understand one thing is more, that we can divided this whole line into zones. Suppose we have these 4 zones. 100 km lines is divided into 4 zones. So, now we have 25 kilometers zones, and suppose we have a fault in that zone. So, the power system protection schemes, or you can say the distance protection scheme, will responsible to operate or to protect this section. So, suppose we have a 4 type of distance relays, one is for this section, one is for this section, and one is for this section. Suppose section 1 or zone 1 protection scheme will operate. So, we can understand that the fault is occur in the zone 1. So, we does not want to check the zone 2, 3, 4. We are highly focused to check the zone 1 only, because zone 1 is responsible. So, we does not want to check the another zones, because we can understand the distance relay of zone 1 is operated, so that the fault is in the zone 1. If the distance relay of zone 3 will operate, so we can understand the fault is between these two lines or in zone 3. So, that is why we can sectionized, or we can divided a whole line into zones or into sections. Now, what are the backup protection? Backup protection is very important. If you are talking about the protection, as you know, we have some primary protection and secondary protections, and secondary protection or backup protection is that we want to ensure that the protection scheme does not fail, or we want that our protection scheme will not fail at any cost, at any rate. Suppose we have a first line of defense. So, this line of defense is going to fail with some reasons, so that we have a second line of defense. This will operate and this will protect our power system. This line of defense, for example, suppose will not operate. So, we have another level, another line of defense. So, these line of defense will operate. So, we have some different type of line of defense. These line of defense, secondary line of defense is called the backup protection. A circuit breaker or protection relay may fail to operate, maybe. In important system, a failure of primary protection will usually result the operation of the backup protection, and backup protection having some margin in the time. Suppose the primary protection will operate in 0.3 millisecond, so the backup protection will always operate after that 0.3 millisecond. So, the backup protection first waits to the primary protection. Backup protection first waits to the primary protection, then backup protection will operate. Now, we are going to move our second topic, that is current transformer. So, the current transformer basically is the type of instrument transformer that is designed to produce an alternative current in the secondary winding, which is proportional to the current being measured in this primary. Rather than, if you comparing the current transformer with the normal transformer does not have this property that secondary current is proportional to the primary current. We have some different type of characteristic. So, but in the current transformer, the secondary current is directly proportional to the primary current. So, this is the property of the current transformer, so that when is fault is occur, after the fault the value of the current will increase in the faulty section, so that this transformer, current transformer, the secondary current will also increase, so that we can detect that, or we can calibrate the fault current in terms of secondary current. So, we have some calibration, or we have some transformation ratio. So, that we can understand that if we have a such type of transformer CT, suppose 5000 by 10 ampere, or you can say 5000 by 5 ampere. So, suppose secondary having 5 ampere current. So, in 5 ampere current we can understand the primary also having 5000 current, because CT having ratio 5000 to 5. If the secondary having some 4 ampere current. So, what is the meaning? Same, we can understand that the primary having 4000 ampere current. So, that is some transformation ratio. The current transformer reduce high voltage current to a much lower value of provide a convenient way of safely monitoring the actual electrical current flowing in the AC transmission line using a standard ammeter. So, that we are going to reduce the current level. Now, we can read, or we can check this current with the help of some conventional or some basic ammeter. So, the principle of operation of a basic current transformer is slightly different from the ordinary voltage transformer, as I told you earlier. The current transformer produces an output which is proportional to the current flowing through the primary winding as a result of the constant potential on the primary. We have some constant potential, but the value of current will increase. So, that this increment in the current will lead to the increment in the secondary current. Suppose the primary having some 6000 ampere current. So, that this will lead to the secondary of 6 ampere for this 5000 by 5 ampere type of CT. With this diagram you can understand this is the primary, and with this primary we have some hollow core, and this hollow core we have some winding, and this winding is called the secondary winding. So, we have some primary, and this primary and the secondary is magnetically linked with each other with the help of flux. So, that when current in the primary will move, and this current will reflect the current in the secondary, and this secondary current can be detected by the help of ammeter. So, we have a main conductor and the secondary winding. So, this is a circuit symbol of the CT, and basically CT can show by this symbol. We have this line, and we have this type of helical symbol. So, this is a symbol for CT. This is a current transformer. So, in the current transformer we have a heavily line current, and we have a primary CT, and this heavy line of current is linked with the another CT. So, we have primary having some low turn or single turn you can say, and secondary having a very different type of turn. So, we can connect our ammeter in the secondary. So, our ammeter can read the reduced value of current, because primary having a very high value of current, and the primary of the current transformer will always fix or connected in the series of the line. So, we have a line, so that we want to know the value of current in that line. So, we are going to connect the primary of the current transformer in series with this line. Now, due to this type of arrangement, the current transformer is often refers to a series type of transformer, because as I told you that the value of current which we want to measure connected or pass through the primary of the current transformer. That is why we can say that the series transformer for the current transformer. The secondary winding, however, may have a large number of coils which turns on a laminated core low loss magnetic material. So, such core having a large number of turns and the large cross sectional area, so that the magnetic flux density created low using much smaller cross section area of wire, depending upon how much current must be stopped down, and tries to output a constant current independent of the connected load. So, we have some magnetic field density principles according to that. Now, the secondary of the current transformer having a two type of current. Two standard are there, one standard is 5 ampere and one standard is 1 ampere. So, 5 ampere and 1 ampere is both standards are running. Now, we are going to discuss the type of current transformer. So, we have a three type of current transformer: wound current transformer, toroidal current transformer and bar type current transformer. We have some wound type current transformer. So, the transformer primary winding is physically connected to the series with the conductor that carries a measured current flowing through the circuit. The magnitude of the secondary current is depend upon the turns ratio of the transformer. So, this is the picture of the wound type current transformer. This is primary and this is secondary. So, this is primary and also have a secondary terminals which is not shown in this figure. So, you can connect the primary with the series with the line section, so that the secondary will lead or secondary will gives you the value of the current. The capacity they are designed to measure the current from 1 ampere to 100 ampere. So, this is capable to measure the current from 1 ampere very lower value to 100 amperes. The most common one of the wound type transformer is that this is very common. Wound type provides excellent performance under the wide operating range. Typically, the wound type is insulated only 600 volt. So, you can say the voltage limitation is there, the voltage limitation is very low up to 600 volt. Now, the second is bar type current transformer. So, this is a bar type current transformer, you can understand this is a bar type. So, a bar is there. This such type of current transformer used to actual cable or bus bars of the main circuit as a primary winding, which is required to equivalent a single turn. So, primary is a single turn, therefore, fully insulated from the high operating voltage or the system and are usually bolted to the current carrying devices. So, bar type having this type of structure, we have a bar type primary, and this bar type primary having some secondary, and secondary is that, so that we have some fixed bar. Through this bar the high amount of current will flow, and we have a magnetic linkage of secondary to the primary. So, this is a primary and we have some coil or we have some core, on that core we have secondary. So, we can understand this is primary and this is secondary. And if you are talking about compared to the wound, so in wound type we have both of the winding on the same core. So, primary and secondary. So, this is the difference between wound type or bar type. So, this is the bar type structure. Its physical appearance we can understand, this is a bar type structure. So, we have bar type has some bar, and with the help of this bar you can through this current through this bar type transformer. Now, second is toroidal or window current transformer. So, toroidal or window current transformer having some such type of structure, these having some window. So, in this type of transformer we does not have a primary, visible primary. So, we want that, suppose we want to check the current in this line. So, we have a some plug structure. So, we open this plug and we are going to put this type of window CT on that line. So, physically there is no touch, but electrical, or you can say the physically there is a no touch, but magnetically these two lines are connected through some link. So, you can understand the wire or primary current will flow through this section or through this section. The primary is same as the your working line. Your working line will work as a primary. So, do not contain a primary winding. Instead of the line that carries the current flowing in the network, it is threaded through a window or hole on the toroidal transformer. So, the primary is flowing through this hole. The window CT are the most common, they are constructed with no primary winding and installed around the primary conductor. The electric field is created by the conductor, and this electric field is measured by this window type of CT, and with the window side type of CT will gives you the current of the transformer. Some measuring device also, we have some multimeter, we also have some multimeter having this type of such type of principle. So, that this multimeter have a no physical connection or no electrical connection. We have some clip, and this clip is fixed on the current carrying conductor. So, these multimeter will also gives the reading of the current. Again, last is bushing CT. So, bushing CT is what that bushing CT is a CT that is used to, or you can say this is a window type of CT. So, this is the CT that is used to carry or find out the current of the transformer. In transformer we can easily understand this is such type of bushing CT. So, this is the terminals of the transformer, high voltage terminals. So, bushing CT is there. So, with the help of some bushing CTs we can measure the value of current, and this is bushing CT is a part of the transformer construction, transformer body. So, in generally we hardly find out where this CT is placed, because this is part of the transformer. So, this is such type of CT. So, these are the some types of CTs. Hopes you can understand such type of different type of CTs. In next lecture we will discuss some more important and more prominent topic of the power system protection. Thank you so much. Have a nice day.